You might have come across this definition of continuity that if we can draw the graph of function without lifting a pen, then we say that the function is continuous. That is true, but there is an exception as well. A function can be continuous and still can be drawn with lifting a pen. So, hi, I am Muskan from Cheenta, and today we'll be solving a question from ISI M.Stat 2022, problem number 6, and learn the concept of continuity in piecewise functions. Let's get started. In this question, we are given that a function is defined as minus ax minus b if x is less than minus 1, a square x square plus b if x lies between minus 1 and 1, and 5x square plus 1 if x is greater than 1. This is a piecewise function. And we have to find how many distinct pair AB exist such that the function is continuous everywhere. So, since we can see that this is a linear function, and linear function is continuous everywhere. But the problem is, the function is changing. F of x is changing at point minus 1. And that changes to a square x square plus b. So our possible points of discontinuity, also abbreviated as PPOD, points of discontinuity, are minus 1 and 1, because the definition is changing there. So, and as the function is continuous, the left-hand limit and the right-hand limit should be equal. That is, limit x, as x approaches to minus 1 negative, f of x has to be equal to limit as x approaches minus 1 from the positive direction should be equal. Let's find that. So that means minus a x minus b as x approaches minus 1 should be equal to limit x approaches minus 1 a squared x squared plus b. Let's figure that out. Plugging in the values minus 1, we'll get a minus b is equal to, plugging the value minus 1 here, we'll get a square plus b. So we get this relation a square minus a has to be equal to minus 2b. That is first equation. And second equation we'll get when we plug in the value 1. That is the continuity at 1. So the left-hand limit as x approaches 1 is a square x square plus b, and the right-hand limit as x approaches 1 is 5x square plus 1. Plugging in x is equal to 1, we get a square plus b is equal to 5 plus 1, that is 6. And also from here we can solve for that. This is equal to 6. That means a minus b is equal to 6 and a square plus b is equal to 6. We can add these equations and we'll get k plus a square is equal to 12. That is a square plus a minus 12 is equal to 0. We'll get a square plus 4a minus 3a minus 12 is equal to 0. So solving the value of a, we'll get minus 4 and 3. Putting it in this equation, we'll get the values of b. So b is equal to a minus 6, that is equal to minus 4 minus 6 minus 10, and the second value is 3 minus 6, that is equal to minus 3. So there are two pairs that are existing that will make this function continuous. 3 minus 3. Yeah, so that is how we can find the continuity of a piecewise function. An interesting fact, a function can be continuous even if we are lifting the pen to draw it. And that is the continuity at isolated point. If a function is graphed something like this, maybe it's continuous in some interval, and then it is defined this, maybe at just one point. That means there is nothing in the neighborhood of it. This continuity is isolated point continuity. So this is how we solve the question of continuity of piecewise function. You will see many questions in many competition exams based on this. We can also incorporate the concept of differentiability in piecewise functions that we can see in later classes. Thank you. Hope you enjoyed.